In the last section, we talked all about using synthetic division to find that something was a zero and then being able to factor the polynomial based on knowing that zero. Well, it was nice in the last section we were just told what to use. However, that's of course not real life. We don't just know what the zeros of a polynomial are. So in this section, we're going to talk about how we can find or pick good things to try to discover what might be a zero. Okay, there's a way to make educated guesses on what zeros we have. The rational zeros theorem is the main theorem we're going to be using. Okay, this says that if you have a polynomial with integer coefficients, and this is key, okay, it has to be integer coefficients, so the coefficients can't be fractions, then all of the rational zeros of the polynomial can be written as p over q, where p is a factor of the constant term of f, and q is a factor of the leading coefficient of f. Okay, now this sounds a lot more complicated than it is. Let's just look straight at an example and we'll see what it is, okay? We're going to look at, here, we've got a polynomial with integer coefficients. We look at the coefficients of, the factors of the constant term and the factors of the leading coefficient. Now for this one, the factors are very, very easy. The only factors of 3 are 1 and 3, -1 and -3. Okay, we're just looking at the integer factors of the constant term. We also look at the integer factors of the leading coefficient, which are 1, 2, -1, and -2. Now, because we always have a positive and a negative, I'm usually just going to write plus or minus, and then I've got my 1 and my 3. And then we divide the factors of the constant term by the factors of the leading coefficient. So I'd do down here the 1 or 2. And the plus or minus carries through, so I like to do plus or minus and then use this as my fraction. So we look at each thing on top divided by each thing on bottom. So 1 divided by 1 is 1. 1 divided by 2 is 1/2. 3 divided by 1 is 3. And 3 divided by 2 is 3/2. Okay, so it's plus or minus each of these 4 things. So I've got 8 possibilities here. And the rational zeros theorem tells me that any rational zero of this polynomial has to be one of those 8 options. Okay, so then we can start trying things out. So we do synthetic division, and we put our coefficients inside. So 2, -3, -8, -3. And then out here, we just start testing these numbers. Okay, so I'm going to go start with 1, just positive 1, see if it works. So bring my 2 down, 2. 2 times 1 is 2, -3 plus 2 is -1, and -1 times 1 is -1. -8 plus -1 is -9. -9 times 1 is -9. And -3 plus -9 is -12. Okay. Well, we did not get a 0 here. That means, since our remainder is not 0, that 1 cannot be a 0 of the polynomial. So that means it didn't work. So I move on. I'm going to erase my work and try the next number. I'm going to jump to the negative now. -1. Bring the 2 down. 2 times -1 is -2. -3 plus -2 is -5. -5 times -1 is +5. -8 plus 5 is -3. -3 times -1 is +3. And -3 plus 3 is 0. Okay, I now have gotten a remainder of 0. And that means that -1 is a 0 of the polynomial. So that means I can take this polynomial and write it as x plus 1 times, and then those are my new coefficients, 2x squared minus 5x minus 3. Now this quadratic we can just factor. if we're comfortable factoring. So we've got a 2x squared there, so we're going to have a 2x and an x, and it looks like we're going to be able to do with a -3 here and a +1 here. That's going to give us a 2x squared minus 6x plus x, which is minus 5x, and then the -3. So there's our factored form, and now we can get all of our zeros. We have our x equals -1. From this one, we get x equals a -1/2. Notice that that is in our list. And here we get x equals 3, also in our list. Okay, so now we could have just kept trying. In fact, let me go ahead and show you that right here, we could have just kept trying numbers. And notice if I try I'm going to try a -1/2 here and show you what happens. You bring the 2 down. 2 times -1/2 is -1. -5 plus -1 is -6. -6 times a -1/2 is 3, and -3 plus 3 is 0. Okay. Now notice that this gives us, okay, we have an x plus 1, and then this gives us an x plus 1/2, and this gives us 2x minus 6. Notice it looks different. However, if you were to pull a 2 out of this factor here and put it with this one, we'd get a 2x plus 1, and then right here we'd end up with just x minus 3. We'd end up with the same thing. So we've just caught that constant that's been kind of shifted around. Okay, neither one is more right than the other. They just look different, and of course they all have the same zeros. Okay, so here's another one. Let's go ahead and try it out. Okay, we want to find out the real zeros of this. We don't know any zeros, but we can use the rational zeros theorem. So we're going to take the factors of the constant term. So the factors of 8 are plus or minus. We've got 1, 2, 4, and 8. And we divide those by the factors of the leading coefficient, which in this case is 1. Well, the factors of 1 are just plus or minus 1. Okay, so the division then just, well, each of those over 1 is just itself. So we get plus or minus 1, 2, 4, or 8. All right, so we've got the positives of these and the negatives of these. And we just start testing them out again with synthetic division. So we do our bracket, inside we do our coefficients. So we've got 1, -2, -7, 16, and -8. Okay. Now, it doesn't really matter what order you check these, all right? You can go in any order you want. Just make sure you're keeping track of what you've tried so you don't start retrying things, all right? I like starting with small numbers because it makes the actual arithmetic a little bit easier. So I'm going to put a 1 here, start with 1. And at this point, I'm going to go ahead and trust that you're comfortable with synthetic division. If you're not, I just recommend practicing. Just keep practicing it and you'll get really comfortable with it. Okay, oh, that's a positive. So it turns out that 1 worked for us, all right? And because 1 worked, that tells us a factor of our polynomial x minus 1, and that x equals 1 is a 0 of our polynomial. Now we can keep going, forget about the 0, and just use what's here and try something else. Okay, we can keep going. Now, just because something has worked once doesn't mean it won't work again, because it may be a 0 of multiplicity more than 1. So let's try 1 again, okay, and go through our synthetic division. And look at that, it actually works out for us again. We got another 0 at the end. So that tells us that we actually have another x minus 1. I'll go ahead and put a squared there. And this right here tells us that what we're left with is an x squared. Notice we did 2 things, so we dropped our power by 2. So x squared, and then 0x minus 8. I like to always write out my factored form once I've got down to 3 terms here, because once you've got 3 numbers, that means you have a quadratic. And I like working with quadratics because we always know we can get the zeros of a quadratic. We can either factor it, solve it directly for x, or use the quadratic formula. So once you've got to a quadratic, I'd recommend just jumping straight there and stop worrying about testing things, okay? So I've got x minus 1 squared times x squared minus 8. Now to get the rest of my zeros, I just need to get the zeros of x squared minus 8. Here we can just add 8 to both sides and then take the square root. We get plus or minus the square root of 8, which is 2 root 2. Now notice that these zeros, 2 root 2 and negative 2 root 2, are not in this list. That's fine because the rational zeros theorem says all the rational zeros are of this form, okay? Well, 2 times the square root of 2 is not a rational number. Okay, so you're not always guaranteed to find all of the zeros just from this list, okay? So once you get down to a quadratic again, just go right to writing out the quadratic because then you'll find the zeros and you won't waste time checking things that don't work, you know? Like here, if I had kept trying, well, I've tried one, but there's 7 other things to try. If we didn't go straight to the quadratic, we would have tried 7 other things and none of them would have worked. And then we would have been like, oh, shoot, I should probably go back and write this as a quadratic. Okay. So we've got our zeros. Our zeros are x equals 1, which has a multiplicity of 2, and then x equals 2 root 2, which has a multiplicity of 1, and x equals negative 2 root 2, which has a multiplicity of 1. All right. Now, this extends to just solving equations. Okay, instead of just finding zeros of a polynomial, if we have a polynomial equation, meaning one polynomial equal to another, we can use this technique because all we need to do, again, is move everything to one side. So if we subtract the 3x to the 4th over 6x cubed, and then subtract the 8x squared over plus 3, then we've got a 0. So really what we're doing is we're looking for the zeros of this polynomial. Okay. Now we know that the zeros of a polynomial with integer coefficients, we have plus or minus the integer factors of the constant term, so 1 or 3, divided by the integer factors of the leading coefficient, so 1 or 2. Okay. So that's plus or minus 1 over 1, which is 1, or 3 over 1, which is 3, or 1 over 2, which is 1/2, or 3 over 2, which is 3/2. And these are the things that we need to check. So we can do our synthetic division. We list out the coefficients: 2, negative 3, 6, negative 8, 0, and 3. Notice the 0 because there's not an x term. Okay, that's the most common mistake with these synthetic division things. Okay, make sure you're checking to see if there's a missing term that needs to be a 0. Okay, we need to check these numbers. It doesn't matter what we check first. I like small numbers, so I'm gonna start with 1. Bring the 2 down. Multiply, and again, I'm gonna assume that you are comfortable with synthetic division and just go through this real fast. Oof, and 1 worked. How lucky are we? All right, let's try it again. Remember, when something works once, it can still work again. So just try it again. Okay? You just try it until it stops giving you a 0 at the end. So. Oh my goodness, and it worked again. That is amazing. Let's try it again. It could work for all of them, really. All right, it didn't work for that one. So 1 only worked twice. So at this point, we know that we're at an x minus 1 squared for our factor. Let's go ahead and get rid of this last time that we tried the 1 because it didn't work for us. Okay, and let me make another comment now about another technique that we can do to make life a little bit easier for us. Okay. We know that when you end up with 3 numbers, you've got a quadratic. Okay. Another thing to look at is if you have 4 numbers here, that means you've got a cubic, and some cubics we are able to factor by grouping. So what you should do is look at the numbers and say, would I be able to factor this by grouping? Okay, and notice if you do group these, you could factor a 3 out of this, and you'd have a 2 and a 1, the same as that. And that tells you factoring by grouping is going to work, which is pretty awesome. So let's go ahead and do it. We've got our 2x cubed plus x squared plus 6x plus 3. Okay, and we're going to group here. So for the first one, we can factor an x squared out, and we're left with a 2x plus 1. And for the second one, we can factor a 3 out, and we're left with 2x plus 1. So, for our factored form, we still got our x minus 1 squared. Then we have a 2x plus 1, and we're left with x squared plus 3. Okay, we are finding zeros here. So we have our x minus 1 equals 0, so x equals 1 with a multiplicity of 2 because of that exponent. The 2x plus 1 gives us x equals a negative 1/2, and that has a multiplicity of 1 because the exponent on that factor is 1. But x squared plus 3, notice if we try to solve that, you subtract 3 from both sides, you get x squared equals negative 3. If you try to take the square root, you get the square root of negative 3. That's not a real number. Okay? Find all the real solutions to this equation. Square root of a negative is not a real number, so this doesn't give us anything. Okay? The solutions are simply the zeros that we found. So we found x equals 1, x equals 1, and x equals negative 1/2. Those are our solutions. Okay, this is a long process, I know, but it's really important to get fluent with this. So we're going to keep doing some examples. So we've got this example here. We're going to find the real zeros. We find the integer factors of the constant term. So that's 1, 2, 3, and 6. Okay, the numbers that go evenly into this. Divide by the integer factors of the leading coefficient, which is 1, while the only integer factors of 1 are plus or minus 1. So while each of these numbers divided by 1 is just those numbers. So we have plus or minus 1, 2, 3, or 6. And these are the things that we need to try. All right, so synthetic division, 1, negative 2, negative 5, and 6. And you pick whatever you want to try it here. I like small numbers. I'm going to start with 1. Bring the 1 down, multiply, go through your synthetic division, and we're looking for a 0, and look at that, we have a 0. Okay? And once you've got 3 numbers here, you know that's a quadratic. So that tells us we're at x minus 1 times x squared minus 1x minus 6. And that quadratic we want to factor more. And that's actually not too bad. That factors as an x minus 3 times an x plus 2. So we get our zeros. We've got 1, 3, and negative 2. And notice that each of those is in the list that we found from the rational zeros theorem. So those are our 3 real zeros of that polynomial. Okay. How about this one? Can we find the zeros of this polynomial? Go ahead and take a second to pause the video and see if you could find the zeros of this. All right, this problem was designed to test you. Did you just do the same thing we've been doing? Did you find the zeros, or sorry, the factors of 10 and divide by the factors of 2? Okay, and did you then go through and test them all? Well, it works. Okay, but it might work. But this one, okay, is actually a quadratic form. We saw quadratic forms in a previous section. And now I don't remember which one it was. I think it was maybe 2.1. And quadratic forms are nice. We can do a little substitution. Let u equal x cubed, which means u squared would be x to the 6. And that's what we have here. So this is 2u squared minus 9u plus 10. So we can factor this, hopefully. Okay, we've got a 2u and a u, and I'm thinking minus 5. Oh, maybe it doesn't work. Maybe I don't think it does work. Ooh, let's use our quadratic formula. Let's do it. Oh no, I think it does work. I'm sorry. 2u and u. I'm thinking 10 and 1, 5, and 2. Yeah. -2, -5. There we go. That works out. Okay, so this factored. Ooh, and this is good. We've got this equal to 0. And notice that, well, the u is x cubed, right? So we had 2x cubed minus 5 times x cubed minus 2. Well, for our zeros, we have 2x cubed minus 5 equals 0, and x cubed minus 2 equals 0. And we can solve each of these. We can add 5 and divide by 2. And here we can add 2 and then take the cube root. So here we get x equals the cube root of 5 halves. And here we got x equals the cube root of 2. Well, those are our only two zeros. Each of them has a multiplicity of 3. But these are not rational numbers. You know what that means? And you probably found this when you tried this. All of the rational combinations you came up with, plus or minus 1, 2, 5, and 10 divided by 1 and 2. That's a lot of them. Okay, there's 8 combinations here, and then plus or minus. That's 16 different numbers. If you went through and tried all of those, none of them worked. And that was probably really frustrating. Okay, but it's because we weren't being smart about how we did this. This is a quadratic form, and getting the zeros, recognizing it as a quadratic form was a lot easier. In fact, it's the only way we could do it because none of our zeros were rational zeros. So the moral of the story for this problem is do not just assume one way of solving a problem. Okay, remember all of the tools and techniques that we've learned, and that will